Welcome to our review on responding to osmotic challenges. So the first thing, and one thing that hopefully you do know anyway, is that you should be drinking about 2 litres of water a day. Now 2 litres is the recommended amount, and that's obviously plenty to get your cells working properly and to keep your brain hydrated so you can keep thinking nice and adequately. But that doesn't mean that you need to constantly be drinking 24 hours a day, so you don't have to go and refill your water bottles in the middle of a lesson, etc. One thing that you should also know is that you can die from water intoxication. And a good example of when this actually happens is if you're playing around with drugs like ecstasy. And the picture at the bottom there is of a girl called Leah Betts who actually took half an ecstasy tablet on her birthday, and then because it interfered with the way that her water balance was controlled inside her body, then she actually ended up dying of water intoxication. She basically drunk herself to death with water. So not something that'll happen if you're just drinking normally, but if you start playing around with recreational drugs, then it does increase the chance of problems. So if you don't have enough water in your body, what happens is you've got a reduction in the water potential of the blood plasma. Now, as a result of that, your body's thirst response is triggered. So this means an impulse is going to travel to the brain to tell you to take on more fluids. So it tells you to have a drink. And your kidneys will also produce less urine. If you were to, for some reason, decide to ignore that signal to take on water, then you would run the risk of dehydration if you did so for a prolonged period of time. So one of the favourite comments that I get from some of my students is that they tell me they're all dehydrating when I don't let them go and fill their water bottles up in the middle of a lesson. Now, at no point are they suddenly all sort of getting very dizzy, they're not sort of suffering with headaches, they're not suffering with a severe lack of energy. So chances are they're just thirsty, not dehydrated. I've not honestly checked their urine because that's a little bit weird. But you will also have this dark concentrated urine if you are dehydrated, as we've already looked at previously. If you have a prolonged period of dehydration, then this is where you could see damage to the kidneys and the liver, and if it persists for even longer, there is the risk of death, which is obviously not a good thing. If we consider the other scenario now where we have an excess of water, then the blood plasma water potential is going to exceed that of the cells. So that's going to give us a very bad situation in terms of what's going to happen to our blood cells, because what we find there is that water is going to move into those cells and possibly cause them to undergo lysis. So our kidneys will produce a larger volume of urine to try to reduce those water levels within the blood plasma to avoid that scenario. So if we have that scenario where a large amount of water is consumed very rapidly, then water is going to move into your cells by osmosis, which can cause lysis. So that's the bursting of those cells. And as we've already established, blood cells going pop isn't a great thing in terms of their ability to carry out their role. The other problem we've got is that it's also going to reduce the concentration of sodium within the blood plasma, and we need sodium for our muscles to function properly. So what we find is that that could lead to muscle cramps, seizures and confusion. If we have water moving into the brain cells, then that's where it may lead to death. So what we need to do is ensure that we don't have vast quantities of water being consumed in a very short space of time. The last thing we're really going to consider are 3 terms that we've encountered when we talked about osmosis. So we've got hypertonic, which is where they contain high levels of glucose and salts in a solution. Hypotonic, which contain low levels of glucose and salts. And then Isotonic, which is the concentration of ions within the actual solution, is the same as that in blood plasma. So just to recap on what happens in osmosis when we use these different solutions. If we place red blood cells in a hypertonic solution, then water is drawn out of the red blood cells and they shrink and shrivel. If we place our red blood cells in a hypotonic solution, then the water moves into the red blood cells and they expand before bursting in that process called lysis. And finally, if we place them into an isotonic solution, then the red blood cells don't change because the concentration of water within the actual solution is equal to that within the red blood cells. Hopefully at the end of this video you can now explain how the body responds to dehydration. You can describe the effects of being overhydrated, and you can also talk about those terms hypertonic, hypotonic and isotonic.